Hi guys, this is our third lecture. Welcome back. This is the second part of our third lecture. We're gonna cover today the technical dimension of how to transform variables in R. And before we go to the topics of this lecture, I just want to mention that I uploaded a mini lecture that it wasn't that short as I expected. I expected to be like a 5 minutes, 10 minutes, but it was 25 minutes. But I think it can be useful. It can be useful with to try to process a little bit more all the concepts related with how R works. What is this idea of objects and how to understand the differences between some of the key operators in R, such as the assignment operator or the pipe that was introduced by these guys of the tidyverse. Okay, so as soon as you can, try to see that mini lecture and tell me if this helped you a little bit to process and to get more familiar with the program. I hope and that help you to do that, because that's the goal of that mini lecture. Okay, let's go to the topics of this third lecture. This is amazing. Is I don't know the extent to which you guys wonder how people try to measure variables in some sciences, such as in physics. How do they try to measure those tiny particles of matter that are very difficult to try to even to conceptualize, such as the atom? So I think this is amazing, and we face to some extent less complex kind of enterprises, such as how to measure, I don't know, regime type or something like that. And even if it is hard, it's probably not as hard as trying to measure other things that are more that is you don't see them in the in your regular life, right? Okay. We were here in this cycle of the data carpentry, right? Or data analysis, actually. So we learned how to import a data set or a data frame, or to create a data frame in R. Later, we learn a little bit about this concept of if a data set is tidy or not, but we didn't get into that part enough because it's kind of very complex. And really, I don't want to give you more information that you can handle for this introductory course. And we say that for this class, we will learn how to transform the variables. Transforming variables is one of the most basic skills that you need to learn in order to use R. And you can learn to that kind of a skill for any kind of a statistical analysis with any kind of software. Even with Stata, you also need to learn how to transform variables with SPSS and so on and so forth. Okay, so more in detail, this was what we covered last week: how to load, import, create data, explore, how to answer this question. We learned that we need to reshape the dataset if it is untidy, but if the data is tidy, we need to clean it, and we learn how to subset and how to export. And the next stage is that we have a clean, transformed data that we can analyze, and we can create graphs and figures, and later we can estimate, test, and we can even conduct linear regression if we have time to do it. Okay. Okay. We need to go to some preliminaries. If you haven't installed the package Data Science Labs, go and do it and call that package with the function library. I'm gonna do it with you guys. Remember to be doing this exercise of replication, which is very useful for you. Okay, so I'm gonna call, I'm sorry, in the console, I need to be in the R script. Okay, so I'm gonna use DS Labs. And I'm gonna use the tidyverse Okay, I think they're done. That's the first step. Okay, and now I need to load the datasets Morders and Movie Lens from the Data Science Labs package. So I use data. Remember that we can upload data or read data that we already downloaded in our computer or that is attached to packages. In this case, we're gonna use 3 data sets that are attached to these 2 packages that I just called in our session. Okay, so I'm gonna use Morder. Is Morder or Morders? It is, one sec, Morders. Morders, I'm gonna use a Movie Lens, and I'm gonna use Star Wars. Yeah, there is a dataset called Star Wars. It's amazing. So once you do this, you're gonna see something like this, like they're in your environment, but they are like a values, and that's kind of crazy. And please don't freak out with this. Don't get panic with this. You just need to click again, and the dataset is gonna be open. Okay, and the dataset already has a name here. The name of that dataset is, for instance, the first one is Movie Lens. So this object already exists. Even if you didn't create it, it already exists in this session. Okay? Okay, so those were the 3 first steps that we needed to do. We're gonna return to those datasets soon. Okay. So, but before we go there, we need to talk a little bit more about variables. Yes, again, variables. We have talked a lot about the scales of measurement, about and the role of variables for conducting analysis about the relationship between 2 phenomena. But now we're gonna talk about another dimension of variables. We can group variables into 2 categories. Variables can be categorical or qualitative, or variables can be numeric, right, or quantitative. They're categorical if they contain no numerical information. In such a way, variables such as gender, the name of countries, jobs, etc., are what we call nominal or ordinal variables. Remember, for instance, our dataset, our map, based on the dataset of Polity4, which is based on regime types, that we had 4 categories to describe a regime type in the world. Full democracies, democracies, anocracies, which are kind of semi-authoritarian regimes, and autocracies that are like a dictatorships. Okay? But remember that we also had another version of the Polity4, an interval kind of version of this variable. This is a numerical variable because you have intervals, and the distances between the intervals make sense, right? So the interval or the ratio level are, of course, examples of numeric or quantitative kind of variables. Okay? You can assign numbers to qualitative variables, but the problem is that, okay, you can assign numbers such as, for example, here you can say that male is 0 and female is 1, or you can convert ordinal variables such as Democrat, Independent, and Republican into more numeric kind of variables. But remember this, you cannot subtract, for instance, in this case, a Republican from Democrat or the opposite, because it doesn't make any sense, right? So what happens if you subtract Democrat to Republican in this case is not number 2 or independent. Similarly, if we have a group of 6 women and 3 men, we cannot say that the average of this group is 0.6 women, right? It doesn't make any sense. So the key lesson here is to be careful and have present in your mind what are the limitations of nominal and ordinal kind of data. And even if you assign numbers to these variables, you, for instance, cannot estimate means, standard deviations, and other kind of measures of central tendency or variability with these variables because they are qualitative kind of variables, right? Okay, so today we're gonna learn how to use one of the packages of the tidyverse. The tidyverse is called verse because it's like a universe related with all these different stages of data analysis, with the importing data, with making a data tidy, transforming data, modeling, visualize, and communicate. And these guys created a set of packages to tackle any of these stages in data analysis. And we're gonna focus today in the package called DPLYR, which I think is Deepler. I think that's the way we pronounce that package, but that doesn't matter. The point is that we're gonna learn how to use this package for data carpentry. Remember that data carpentry is the transformation, manipulation of data for our research interest, okay? This package, the Deepler, has at least 5 functions that are critical that we learn. I just introduced you to the functions select and filter last week. And these functions created a lot of confusion because of probably, I don't know, the use of vernacular terms such as selecting. And we can say in vernacular language, we can say we're gonna select certain values, right? But because these functions have the name select and filter, that can create problems to understand what's the purpose of each one of these functions. But I'm gonna tell you a little bit, like in summary, what are the functions. I'm gonna reinforce, I'm gonna review the structure of these functions, and I'm gonna give you another example of how to use select and filter, okay? So select is used to subset the data set by picking columns by name. So remember, we have a tabular form in our data sets. And what we do with select is to say to R, pick variable 1, variable 3, variable 27, right? And the program is gonna take the whole column. So the original rows or number of rows or observations will remain after this change, okay? Filter is used to subset by keeping certain rows that match a criterion. That criterion can be a value or a range of values of one variable or multiple variables, okay? Once we apply this filter, the program is gonna reduce the number of rows, but it's gonna maintain the number of variables in comparison with the previous version of the dataset, okay? And I'm gonna introduce you to 3 new functions: arrange, mutate, and summarize, okay? Okay, let's review select and filter. I'm gonna be more careful to give you all that is necessary to write these functions in a correct way. I'm gonna focus much more on the syntax, okay? For instance, in this example, I'm gonna highlight with blue color that an object is, in this case, is a data frame, okay? It's a data frame or data set that you already read in R. And what you are doing is that you assign to one object that data set, right? And that data set is going to be transformed according to these functions. I hope that makes sense, okay? And variables will be highlighted will be in color green. Okay, so see the structure of this syntax of the function select and the structure of filter. And we're gonna go to one example in R. Okay, so let's do first we're gonna use the Star Wars dataset. I really like this dataset, and when I saw that it's an actual dataset with the characters, of Star Wars, I said, well, okay, I need to use it in the class. I think it's very cool. So we have in this dataset 13 variables and 87 observations. The unit of analysis here are the characters of Star Wars, such as Luke, Darth Vader, Anakin, so on and so forth. So this is very cool. And what we want to do is first to select some of these variables, not all of them. For instance, I don't care about starships, I don't care about vehicles, I don't care about films actually. So I'm gonna just keep, let me see. So I'm gonna create a new version of Star Wars that will be SW. I'm gonna use Star Wars and I'm gonna use my pipe. Remember to use the pipe always. And I'm gonna say select just the following variables: name of the character, height of the character, weight, I think there is weight, right? I know, mass, and let's say gender. Here's mass, gender, and I think is home. No, species is more interesting. Species. So remember that we have 13 variables for Star Wars, right? Originally. My new dataset, SW, only has 5 variables. The variables that I selected, right? That's what select does in our datasets, okay? The second function, the other function that is important to remember how to use is filter. So remember that filter, as I explained, ask R to retain the rows that follows certain criterion. In this case, that match the value apples, for instance, in variable 1. And what I want to highlight here with this syntax is that you need to use quotation marks when variable 1 in this example is categorical, and you don't use quotation marks when the variable is numerical. Okay, let's go to Star Wars again. So imagine that we want to select only we're gonna select by species only human. Let me check that value is correct. Human, yes. Okay. So now remember that the new version of the dataset has 87 observations. Now I wanted to have, or I will see what happened after I apply filter. So I'm gonna have 35 observations, but the number of variables will be the same. Okay. I want to teach you very quick something interesting that you can do with your pipes. Instead of having several times the same function, you can do it directly. And for instance, you can first select and later you can filter. Okay? All in one command. Look at here. So this new version of the dataset does the same. Oh yeah, that's the same. You have 5 variables and you have 35 observations. It first selected the 5 variables and later filter by the value of one of the variables. Okay, all in once, and created a new object which receive all these changes. Okay, let's try to use the tidy structures and try to read because they can be read. Okay, what we say is R, due to Star Wars, the dataset is Star Wars, or the object is Star Wars, the following things. First, select 5 variables, and then that's what actually the pipe means. Then filter by the value human in the variable species. Okay, so if you go to this new version, you will see that there's only one one value in the variable species is human. You will not see anything else, right? Okay, that's just a review of what we did in the previous lecture. Okay, now we're gonna learn how to use a range, but first, it's very simple. A range is a function to sort out your data and in a particular order. By default, a range sorts the data in increasing order, right? You can use the functions in descent or DESC to tell R to sort the data by descendant order. Okay, and I will use here. Let me check here, so I can use SW2. I can use the same because there's not going to be any dramatic change in my data set. So I can use the same version of the data set. It's just going to be organized, and that's all. And I use arrange by height. Okay. So now it's going to be organized from the lowest level of height to the highest level. So it's going to be from 150 to 200, 202. Okay. But I imagine that I want to do something, I don't know, the opposite with mass. So I want to write here and this, and here I'm gonna use mass. Okay. Now it's gonna be organized again, but from the lowest, from the highest to the lowest level of mass. Okay. Remember that this can be useful for if you want, for instance, to create a list and you want to find the median or the interquartile range. This can be very useful for you guys, especially if you have a small table of a small data set. You can do it even manually. Okay, you don't need to do it actually. The system will help you, but if you want to do it, that can be useful in that sense. So that's the function arrange. Okay, that's arrange. Now we're gonna learn one of the most useful and interesting functions in the set of action verbs in the Dipler, and is the function mutate. So you can use mutate to create new variables based on the values of other variables, right? The first thing that you can do with mutate is to compute mathematical operations to one or multiple variables. If you think in mathematical terms, what you are doing here is to apply a mathematical operator or a mathematical operation to one vector or to several vectors. Remember that a vector is is an object that has different or has at least two dimensions, and you can have many different elements in that vector. That's basically a column in your data set. Okay. For instance, here you can use you can multiply the variable 1 by 3, and it automatically creates a new variable with the result. Okay, let's see it. I'm gonna use again, let's see, I think I'm gonna use again height here. Okay, let's create a new version of this variable because this is gonna change. Okay, mutate, and I'm gonna height times 3, for instance, or 4, whatever. Let's go and see this variable. It creates a new variable called height times 4, which like I estimate that operation. Okay. But it's better that instead of like getting R to do automatically, to create automatically this new variable, it is better if you tell R to create that variable. For instance, in this case, I say, or I wrote R, create this new variable based on the operation of two variables. And something that I do here, that is to divide the value of one variable by another variable and to multiply that value by 100,000, right? This is an important example. This is what is called the rate of events per 100,000 people. And this is very useful in social sciences, especially when you want to compare, for instance, murders or crimes or terrorist attacks or events that are not very frequent in a country. And you want, or could be in a country or could be in cities. And the good thing about this is that you can compare the rate, for instance, the rate of, I don't know, terrorist attacks in one state versus one city versus one village, because what it does is that it uniforms all these these events by the ratio of the population in that territory. So it's a very useful variable, and you need to learn how to do it. So in order to do that in R, I'm going to use our second data set. In this case is murders. So I'm going to create a new version of murder and murders. Okay, I'm going to use mutate. And let me see murders 1 sec. So murders tell us the total of murders in the States. I don't know the year. I think it's 2010. But what I'm gonna do is total is the number of murders in the state for that year. And what I'm gonna do is to create the rate of murders, okay? In order to do so, I'm gonna divide total by population and multiply by 100,000, okay? So I'm gonna create a new variable called rate of murders. It's gonna be equal to total divided by population times 100. Yes, it's correct. So let's see murders. No, let's see more. This is my new variable, rate of murders, okay? In this case, we're gonna have, for instance, that in Alabama is it's like a 3. If we approximate 3 murders per each 100,000 people, and actually it's kind of low in comparison with Arizona, which is 3.6, and you can compare with Delaware, which is, I can actually organize here. So the highest is District of Columbia with 16 murders per 100,000 people. Is crazy. It's very high. Okay. So that's the creation of the rates. That's gonna be very useful for you guys.